So here's a little interactive demo I've made to help people understand how numerical integration works. Let's suppose you've got a Gaussian curve like this one and you want to calculate the area under the curve. Well, that's an example of an integral. The way computers calculate integrals is they add up tiny pieces of area. So each one of these little rectangular strips represents the area that you're adding underneath each of these points. So the white squares indicate the data points along the function that you're integrating, and then the more translucent gray strips indicate the area contribution there. So out at the ends you have very little contribution, in the middle you have a lot of contribution, and you can see that by playing around with these sliders below that tell you where the integration range is. So right now they're both going from -2 to 2, so basically where the thing almost gets close down to 0. As I move these in, I'm basically deactivating part of the integration up here. So when I move this into, let's say, -1 for my x minimum, my integral is only going from -1 to 2. And so I've grayed out this part because it's no longer contributing to the integral, and you can see the integral value here decreased. So when I slide this out here, my integral increases. When I slide it back, my integral decreases. But the important thing is the integral is not changing by a whole lot because I'm not taking away very big strips. Similarly, if I move the x max inward, let's move it down to 1. My integral goes from 1.6 to 1.5, so not a whole lot of change there. But if I keep moving in, let's say I go from 1 to 1/2, I'm going to go from 1.5 to 1.2. That's a much more drastic change, even though I've only gone half the distance that I went before, because out here at the tail I don't have a lot of contribution to the integral. The strips aren't very tall. But if I move inward, those strips get taller and I've got a much bigger contribution to the integral. I mean, you can even zoom in on the central point here, get that inner strip and see what it's contributing, and then you can move this out. You see you're getting a lot more to the integral there, so I don't have to move it far before I get past 1/2 here. But then to get it up to 1, I've got to move even farther out with my bounds here, my x min and my x max. And so you can take this program and you can change the function that it's integrating. So up here is where we set the function to be integrated. Right now I've got this Gaussian function here. Let's suppose we did cosine of x quantity square. Let's suppose we did that instead. And we'll run the program. Now it's giving me this cosine squared graph. I'm not getting a whole lot of the cosine function there, so let's actually make this maybe cosine of x over cosine of 2 times x. I always forget which way those factors go. Yeah, here we've got a nice cool little function right here. So when I change my integration bounds, when I move the x min to the right, at first I lose a lot because I've got very tall strips, but then I don't end up losing them as much, right? I can play around with the right here. I don't change the integral value by all that much. But then when I move it farther this way, I'm losing more of the integral because I'm losing some larger strips there. So the way this works is you set the function in here. That's really the only thing you need to change. You can also change the x min and the x max here, or the dx if you would like to. Here is where we create the display for the function. So we're creating these cells to represent the data points, and then we're creating this list called Riemann to represent those strips, because that's where you're doing the Riemann sum. Let's scroll down. We'll get to that stuff in a little bit. Here's where I create these sliders. I'm using slider and wtext. These are little HTML functions that, they're functions that allow VPython to talk to the HTML part of the web page. So for the slider, you just set what you want its minimum and maximum values to be, and then what you want its current value to be, or its initial value to be. You give it a length. That's just, how much control you want people to have over it. And then you bind to that a function. So here I've bounded this one set xmin and set xmax. And so that's really where the integration is happening, because for the set xmin and set xmax, they both work basically the same way, just changing the different value. Basically, it reads out from the xmin slider the value that it's been set to, and it sets that equal to the value of xmin, and it updates the cells, or makes the caption accordingly. So then after that, we run this update cells function where basically it turns those cells on or off depending on if they're in range. So for each item in the cells, it's going to either, it's going to check for whether we're within range of the slider's position, the X-min and the X-max. It's going to set the color to white, set the opacity to 1. If the sliders go in the opposite direction, if I end up with X-min on the right and X-max on the left, then we end up with a negative integral. I'll show you how that works in just a second. And we change the color to red. But if it's outside of the range, then we dim them, right? We kind of turn their opacity off, turn it to 0.1 so that you can't really see it all that well, just to indicate it's not contributing to the integral. And then we need to calculate the integral. We do that in the integrate function up here, where we go from x left to x right based on where x-min and x-max are relative to each other. And we just do a simple summation of each of these contributions here. So we have integral, we just take each, if the cell is turned on, then we add its y position. If not, we don't bother with it. So we're not actually even integrating the function, we're just integrating the values of the function that we already determined. So we only have to call the function in one pass. And then this sign here is what turns it into a positive or negative integral. Let me show you how that works. So we'll use our Gaussian here again, and let's suppose I move my X-min here, I move my X-max here, and I go past to the other way. So now my X-max is less than my X-min. That's not the way it's supposed to be. But basically that means you're going from the right to the left, and that just means your integral is negative because you are integrating in the negative X direction. So anyway, I hope that's useful to you if you are a student or an educator and you're learning about integration. I hope this is a nice, useful visualization for you. Next time I'll show you how we can turn this into a two-dimensional integrator and go along the X and the Z directions.